Welcome to part 2 of solving systems of equations. This time we're going to focus on the elimination method. When we say elimination, what we want to accomplish is we want to be able to add these two equations together and we want to eliminate one of the variables. It does not matter which variable we eliminate, but we want to eliminate one. So if we look at this equation, the very first one, if we want to add these two together, and let's try to eliminate x. Okay, we could do either one. Let's just try x. We want to multiply this top equation by a certain number that whenever we add it to our second equation, the x's are going to cancel out. That number is -2. Remember, if we multiply one side by it, we have to multiply the other one. So our top equation, once we distribute this in, we get a -2x and then -2. That's just distributing that -2 in. Now the reason that we multiplied by -2 is because when we add these two equations together, the x's become 0. We have positive 2x, we have -2x. We add them together, they are gone. And what we're left with is y minus 2y, so we have -y equals -1 minus 2 is -3. So if -y equals -3, positive y must equal positive 3. We do a similar manner in that we plug this back into one of our original equations. I'm just going to pick the second equation. When we plug it back in, we say y was equal to 3. So instead of y, we have 3. We have 2x minus 1. We add 1 to both sides. We get 4 equals 2x. We divide by 2, and we get x to be equal to 2. Now, we still want to put this in as a point, so x is 2, y is 3. The reason we put this as a point, and this is something that I didn't point out earlier, we have two equations. Both of these equations represent lines. Whenever we solve this system of equations, we get an x value and a y value that are at a point. This point is where these two lines intersect. Again, this point is where our two original equations, the lines that represent those, intersect. If you look at the next one, let's eliminate y this time. We can eliminate either variable, but let's just go with y. In order to add these two equations together, and get our y's to cancel out, one has to be negative, one has to be positive. So I'm just going to multiply the top one by -1. So now we have -y equals -x minus 3. We add these two equations together, we get 0 equals x plus 2. We subtract 2 from each side and we get x equals -2. We go back to one of our original equations. Okay, I'm going to choose y equals x plus 3. When I plug x for -2, I get y to be equal to 1. Our solution is a point, -2, 1. Again, I want you to try the last example on your own to bring into class. The final part of our notes is going to be when there's no solution, infinitely many solutions, or just one solution. We've already dealt with one solution. That's when we cancel these out and there are one x value and one y value. The examples that we did together are examples of where there is just one solution. There's one x value, one y value that make this true. If you try to eliminate variables and both variables eliminate, okay, you're left with one of two things, either a true solution or an untrue solution. If it is an untrue statement left, so 6 equals 3, something like that, that means that there's no solution. There's no point that these intersect. These lines are parallel. If you are left with a true solution, like 6 equals 6, then we're talking about the same line.